In this video, we will be comparing some of the best modern tanks in the world and compare them with each other. This will not be a typical top 10 ranking, but a more comprehensive comparison about the tank's capabilities. We will be comparing the most important features such as protection, firepower, accuracy, fire control, and survivability. First off, we will start comparing the fire control, which defines the ability to accurately hit and destroy enemy targets. When comparing modern main battle tanks, it becomes clear that they are all very capable and formidable machines. They all have a digital fire control system, using a stabilized gun with a laser rangefinder and a ballistic computer, which calculates all the needed information to accurately hit targets at long range, allowing very accurate first-round hit probability against moving targets while on the move themselves. Basically, all top-line modern MBTs have the ability to hit other tanks with high accuracy. But there are still some slight differences in the optics and situational awareness for every tank. During the Cold War, a new type of optic was used, the thermal imaging. Unlike traditional optics, it uses the heat signatures of the surroundings to locate enemy targets. It works even in harsh weather conditions like rain and fog, where the visibility for the normal optics is very low. The Soviets didn't have this technology during the Cold War. Instead, they had to rely on a simple infrared light, which was not quite as useful as the true thermal sight, which gave NATO tanks a major advantage in some situations, as they could spot and destroy Soviet tanks from a range where the Soviet tanks could not shoot back. The only Soviet-Russian tank to have a thermal optic at that time was the T-80 UK command tank in 1991, which was only produced in very limited numbers after the Soviet Union had already collapsed. With the new thermal optics, provided by the French Thales company, the Russian T-80 UK was very much on the same level or even slightly superior to the M1 Abrams, Leopard 2 and Challenger tanks. But today, it is a common feature in most modern tanks. Almost all modern tanks have a thermal sight, but with different qualities. The first thermal sights were rather primitive. Targets appeared only as a small glowing dot. It was difficult to distinguish between friend or enemy vehicles, which resulted in many friendly fire incidents in 1991. But the quality of thermal sights have since been improved. Today, the newest generation of thermal sights incorporate high-definition imaging quality. This gives the M1A2 Abrams, for example, the ability to differentiate between different vehicle types by their thermal profile, even at 4 kilometers range. Other examples of tanks which have high-definition thermal sights include the French Leclerc, the German Leopard 2A7, the Ukrainian BM Oplet, the Turkish Altai, the Russian T-90M and T-14 Armata. Another improvement was the commander's own independent thermal sight, which gave the commander the ability to search for targets, while the gunner is using the main gun's sight to look for other targets, which gives this tank a hunter-killer ability, greatly improving the situational awareness over the battlefield. Some of the first tanks to have this ability were the M1A2 Abrams, Leopard 2A5 and Leclerc. Many other countries followed this trend shortly after. But most Russian tanks still don't have this ability even today, with the only exception being the T-90M and T-14 Armata, produced in limited numbers. A new feature introduced to the fire control functionality was the use of automatic target tracking, ATT, which basically enables the tank to aim and shoot the gun automatically on enemy targets with faster reaction time and better accuracy than any human gunner. This feature is especially useful to accurately hit moving helicopters as well, which is a difficult task, even for skilled gunners. This option gives some tanks the ability to act as a close-range anti-air weapon and to effectively defend itself against low-flying attack helicopters, which are a serious threat to any tank. But only very few tanks have this ability, such as the new Russian T-90M, the Israeli Merkava Mark IV, the South Korean K2 Black Panther, and the Turkish Altai. Another special feature that some tanks have nowadays is the use of radar, which allows them to spot enemy targets such as tanks or helicopters much faster, which really helps to increase the overall situational awareness, as it gives a much clearer picture of the surrounding battlefield. Coupled with the automatic target tracking ability as mentioned before, this gives the tank a big advantage on the battlefield. Another important difference in terms of fire control is the fact that some tanks have a digital battle management system with digital display maps, showing friendly and enemy forces on the screen, which gives the commander a much better picture of the surrounding battlefield and increases situational awareness. This allows to share important information with other friendly tanks on the battlefield and allows for better coordinated attacks to ambush enemy forces. It also decreases the probability of friendly fire, which has been a serious problem for the US in the past. Some of the first tanks to have such a digital battle management systems was the US M1A2 Abrams, the French Leclerc, the Swedish upgrade of the German Leopard 2A5, and the Chinese Type 99. This system gave these tanks a big advantage on the battlefield at that time, as they had much better situational awareness over the battlefield than any other tanks. Even though the armor package for most tanks is still classified, we can draw some conclusions on what basic information we have. Some tanks like the Abrams, Challenger, Merkava, Leopard and T-90 have already seen intensive combat, and although they never faced any modern main battle tanks yet, they were confronted with modern anti-tank missiles. We have enough pictures and videos so we can estimate and draw some conclusions how effective the armor works. All modern main battle tanks use some kind of composite armor, a mix of different materials with spaced armor, mainly to defeat the heat jet of a missile, but it is also effective against kinetic energy projectiles as well. The first tank to use composite armor was the Soviet T-64 and T-72, which at the time were superior to any NATO tanks. Subsequently, the Leopard 2 was one of the first Western tanks to use composite armor, together with the American M1 Abrams and the British Challenger 1. Now the Western tanks had something similar, and in fact even better than the Soviet tanks. Because the T-64 and T-72 only used rather primitive and simple composite armor, whereas the new Western MBTs utilized new materials. The armor is strongly concentrated on the front, but the sides and rear are still very vulnerable. Basically, all tanks are vulnerable on their weak side and back. Any modern anti-tank projectile can easily penetrate the thin side and rear armor of any modern MBT. Of course, that's just common knowledge. But it illustrates that any tank can be destroyed when hit on the weak sides and rear. Even the front armor has many weak spots, such as the gun mantelet, the turret ring, and in most cases, the lower hull. In the 1990s, Sweden wanted to buy a new tank. As potential competitors, it considered the American M1A2 Abrams, the German Leopard 2A5, the French Leclerc, the British Challenger 2, and the Ukrainian T-84 Yatagan, which is specially fitted with a 120mm NATO gun, just for this competition. During the Swedish tank trials, however, top-secret classified informations have been leaked. Informations that were never meant to go viral at all. It showed the armor penetration results of the M1A2 Abrams, Leopard 2, and Leclerc. These documents basically revealed the true armor effectiveness of these tanks. So at least for these three tanks, we do know the realistic armor protection. As the results show, the German Leopard 2A5 has by far the best frontal protection out of these three, which is not really a big surprise, however, because the Leopard 2A5 had the thickest frontal armor package. It has very big armor wedges on the turret front, making use of a dynamic non-explosive reactive armor design. Basically what happens when a projectile hits these armor wedges, it breaks and snaps the penetrator, effectively protecting the front of the turret, which would stop any projectile. But the armor of the Abrams was still sufficient enough at that time since most ammunitions, especially the Soviet-Russian ammunitions, could not even penetrate 700mm of armor at that time anyway. The strongest Soviet-Russian round at that time could only penetrate roughly about 500 to 600mm of armor at close range, so it would still struggle against the front armor of the Abrams, meaning that the Abrams was still good enough protected, even if it was not as good as on the Leopard 2A5. During the Cold War, a new type of armor was used for the first time to increase the survivability of the tanks and their crews: the explosive reactive armor. It is a relatively light but very effective dynamic armor design that can increase the protection without increasing the weight much. On impact, the explosive detonates, forcibly driving the metal plates apart to disrupt the penetrator, effectively providing a greater path length of material to be penetrated. The first use of this new type of armor in combat were the Israelis, equipping their M60s and Centurion tanks with explosive reactive armor. It provided good protection against early anti-tank missiles, such as the 83 Maljutka, which has been a serious threat to Israeli tanks in previous conflicts. The Soviets also started to use this new type of armor on all of their tanks, beginning in the mid-1980s. Not only did it provide better protection against missiles, but also against kinetic energy penetrators as well, reducing the penetration chance of NATO rounds. It took the Americans and other NATO countries quite some time to develop an effective counter-weapon to defeat this type of Soviet reactive armor. The early M829A1 shell of the Abrams was not enough to deal with this new Russian armor, but in the 1990s, a more advanced version, the M829A2 and A3 shells were developed, with a much longer penetrator length, using depleted uranium layer, greatly improving the penetration capabilities against the Soviet-Russian reactive armor. Only after the Soviet Union has collapsed had the Americans finally developed a new round that was adequate enough to deal with the Soviet armor. But all other countries still used inadequate rounds which were not able to defeat the Russian explosive reactive armor at that time, since the USA were the only country which used the new M829A3 shell that could defeat the Russian reactive armor. So Germany, France, and Britain would still have big problems when engaging Russian tanks at that time. But luckily for the NATO tanks, the Russian tanks had a big weak spot on the turret front, which was not covered by the reactive armor, because of the big infrared illuminator that most Soviet tanks were equipped with. This was also where the turret armor was the weakest, as Soviet armor design concentrated the thickest armor part only on the side cheeks, but it decreased towards the gun. So the Russian tanks were still vulnerable, even with the reactive armor equipped. But Germany later developed a newer and much better performing round, the DM-53, which was specifically designed as part of the Germany's program, meant to overcome the Russian Contact 5 reactive armor. Especially in combination with the new L-55 gun that the Leopard 2A6 received, it gave this round very powerful armor-penetrating capabilities. In 2003, the USA received a T-80U from Ukraine, which had the Contact 5 armor, so the Americans could test their weapons against it and draw some conclusions in order to develop a counter-weapon against the Russian armor. The result was the M829A3, which entered service shortly after the USA received the Ukrainian T-80U, which indicates that the M829A3 was a direct result of these tests. But Russia, taking notice of what the Ukraine just did, upgraded the components of the Contact 5 armor, adding more explosive and thicker steel plates to the armor block, increasing its protection level to make the Contact 5 even stronger than it already was before, which perhaps made all the efforts that the USA took to develop a counter-weapon to it useless. The new updated Russian Contact 5 made the armor tests that were carried out in the USA completely irrelevant now. But then again, the USA has also developed a newer version of the M829 as well, the A4 version, which was not tested against the newest Russian armor so far. So we still don't know how effective it is against the latest Russian tanks such as the T-90M. Quickly after the collapse of the Soviet Union and the resulting end of the Cold War, many other countries started developing their own main battle tanks, including Italy with its Ariete, France with its Leclerc, Japan with the Type 90, and South Korea with the K1 tank. The Japanese Type 90 was very much influenced by the German Leopard 2A4, and very identical in most places. It was basically a lighter version of the Leopard 2A4 with similar armor design and thermal optics, but it had more advanced sensors, including a passive laser detector, which would warn the crew when the tank is being lased by enemy infantry missile team, to give the tank some time to react. Something the original Leopard 2 doesn't have. It also features an autoloader to reduce the number of crew members needed to operate this tank to only 3 crew members, so a loader is not needed. The South Korean K-1 had in fact already started production even before the Soviet Union collapsed, with at least 250 tanks completed before the Cold War ended. The K-1 was very much influenced by the American M1 Abrams, with the same armor design. But only the early basic version from 1980, which was not sufficient enough to protect against Soviet 125mm ammunition. This version was not on the same level with the later upgraded M1A1 and M1A2 Abrams. It retained the 105mm gun from the early M1, which made it inferior to all other Western tanks having a 120mm gun. But it was sufficient enough for the threat it would have to deal with, the North Korean T-55. Unfortunately, it had only very low number of 7 ready-to-fire rounds in the turret, without blowout panels like on the Western tanks. The K-1 was remarkably one of the most mass-produced tanks after the end of the Cold War, with over 1,500 units completed. Later, they would soon be upgraded to the M1A1 standard, specifically the K1A1, which in return was further upgraded to the M1A2 standard, the K1A2. The Chinese tanks are often very much ignored, but they deserve more respect, as they are in fact some of the very best tanks in the world. All jokes and made in China memes aside, the Type 99 was pretty much one of the most technologically advanced tank in the world and far superior to most other tanks when it entered service in 1999. It was one of the first tank in the world with a digital battle management system, something that only the Abrams, the Leclerc, and the Swedish Leopard 2A5 had at that time. And with a copy of the Russian Contact 5 armor, it also had very good armor protection as well. After the Soviet Union collapsed, Russia had a leftover of 10,000 now obsolete T-72 tanks. Although the T-72 used to be a formidable tank in the mid-Cold War era, but it became quickly outdated in the 1990s. Russia took many efforts to upgrade the T-72 to keep it up to date. One of the best result was the T-90, which was a very capable tank at the time of its introduction. It was the first modern Russian main battle tank produced in large numbers to have a standardized thermal sight, something which all previous Russian tanks were missing before. But Russia only produced around 500 units of the T-90. In fact, most of the T-90 tanks were actually produced by India, which became the biggest T-90 operator in the world, with currently over 2,000 T-90 tanks in active service. Most efforts to upgrade the T-72, however, only resulted in less capable modifications, such as the T-72BA, which still lacked a thermal sight. But in 2006, a more advanced version was presented, the T-72B2 Reactive, which was even better than Russia's best tank at the time, the T-90. The new upgraded T-72B2 featured a brand new explosive reactive armor type Relict, which would also be found on the T-90M upgrade later in 2012. But this version was produced only in very limited numbers, with only around 150 to 300 being upgraded to this level. Beginning in 2013, most of the aging T-72BA were now finally upgraded to the new T-72B3 standard, which gave all the T-72B3 a standardized thermal sight. And in 2016, the T-72B3 was again upgraded to the T-72B3M, receiving new side protection with additional explosive reactive armor modules on the side of the turret and hull, greatly increasing the tank's survivability in urban combat against RPGs. Modern anti-tank missiles are usually tandem heat, meaning two warheads together. The first charge is a smaller one to deal with explosive reactive armor or whatever it hits first, and the second charge is the bigger main charge, which then will penetrate the armor of the tank. Some Russian heat rounds even have triple charge warheads, which is very difficult to stop, even with explosive reactive add-on armor. But reactive armor remains highly effective today. Some good examples are the Russian Contact 5 and Relict used on the T-90, and the newest type Malachit used on the T-14 Armata. Some Western tanks are also equipped with explosive reactive armor now, such as the M1 Abrams Tusk upgrade and the British Challenger 2, which greatly increase the protection and survivability on the battlefield against RPGs and missiles. Another very effective reactive armor is the Ukrainian version called Duplit, literally meaning knife. It uses many shaped charge elements inside the armor block. When triggered by an incoming projectile, the shaped charge elements are activated and cut through the incoming projectile like a knife, effectively destroying the projectile. What makes it even more effective is the fact that multiple layers of this armor are used. Up to 3 layers on the side of the BM oplet, giving it the best armor protection out of any modern main battle tank. This gives the BM oplet unique all-round armor protection levels, even on the sides, which is usually only found on the front part of most other tanks. But the BM oplet is a very rare tank, difficult to produce and manufacture due to the complex reactive armor components. The only operator is Thailand with 49 units. Ukraine only has around 10 BM oplet. Another very effective type of add-on armor is Germany's modular passive ballistic AMP module. It uses non-explosive reactive armor elements, similar like explosive reactive armor, just without the explosives. This armor package can be installed on any Leopard 2 tanks, effectively increasing the side protection of the hull and turret, which increases the survivability of the tank on the battlefield. This upgrade can be found on the Leopards used by Indonesia and Singapore. But the best protection against missiles and rockets can be provided by using an active protection system. The active hard kill protection system intercepts any incoming missile before it even hits the tank's armor, effectively protecting the vehicle. The first idea of active protection system is actually quite old and goes all the way back to the 1960s. Germany and the USA were the first countries to start developing such systems in the 1960s, but none of the systems entered active service, and the programs have all been cancelled because it was deemed too complex and too expensive at that time. Besides, tanks at that time were not even that valuable, as they were produced in large quantities for an all-out war against Soviet armor brigades, where huge numbers of losses would be expected anyway. Tanks were meant to be expendable to be quickly replaced, so there was not really a need for such complex system at that time. The first time such a system was used by the Soviets in the early 1980s, mounted on the T-55. It proved to be very effective in combat. But since it was quite expensive, only a very limited number of Soviet tanks were fitted with this upgrade. In the 90s, the Russians developed a further upgrade of the Drozd, the Arena APS, which improved the vehicle's survivability. But it never entered active service. More than 30 years later, Israel became the first operator to use modern active protection system on a large quantity of their Merkava tank fleet. It proved very effective in 2012 and again in 2014 with a 95% intercepting rate, stopping multiple rockets and missiles, giving the Merkava excellent protection against infantry weapons. But active protection system is not perfect. Like all other systems, it has limits. Another serious problem for active protection systems are the newly developed Russian RPGs such as the RPG-30, which fires a decoy shortly before the main projectile is launched, which triggers the active protection system to waste its shot on the decoy, so the dangerous main projectile can still hit the tank. That's why the newest Russian infantry fighting vehicles such as the T-15 Armata and Kurganets-25 are now carrying 4 ready-to-launch anti-tank missiles, so they can fire at least 2 missiles at the same time in an effort to overcome the enemy active protection system. This, however, is only a serious problem for single-launcher APS such as the Trophy, since it can only intercept 1 projectile at the same time, which makes it vulnerable against such weapons. But other systems such as the Iron Fist or the South Korean KAPS have 2 ready launcher grenades on each side, so they can even intercept multiple projectiles at the same time to protect against the Russian RPG-30. And yet, we haven't even spoken about the biggest threat for modern MBTs, the top attack missile, such as the Javelin or the Spike missile, which flies at a very high altitude to attack the target from above to hit the weak top side, where the protection is usually the weakest. This makes armor protection pretty much useless, as it simply ignores the armor and simply aims for the weak top of the turret instead. Most active protection systems are useless against such weapon, as they have problems defending against such high-angle attacks. At least Russian tanks have some explosive reactive armor on top of the turret to provide at least a little bit protection against such top attack missiles. Although the effect is questionable, it is still better than having nothing on the top, which is the case for all NATO tanks. But then again, Russia doesn't even use such top attack missiles at the moment yet, so it's not a big problem for NATO tanks. The US-American Javelin was the first such missile to enter service in the 1990s, destroying hundreds of Iraqi tanks. It gives the infantry soldiers a very powerful, nearly unstoppable anti-tank weapon, which can destroy nearly all modern tanks on the battlefield. But some active protection systems can in fact even intercept top attack missiles too, such as the new Russian Arena M or the German MAP-DS. Drones have also become a very serious threat to tanks as well on the modern battlefield. But the drones themselves are not invincible either. In fact, drones are very vulnerable to electronic countermeasure jamming. Since they are remotely controlled by an operator, the connection to the operator can be disturbed and disabled with electronic warfare jamming. A new development in laser weapons also provides a good counter against those annoying drones. On the modern battlefield, armored vehicles equipped with directed energy laser will protect tanks and other ground units from drone attacks, which proves that armored vehicles in a combined arms force are even more important today than ever before. This really shows how vulnerable tanks have become on the modern battlefield. Some might even say tanks have become entirely useless. So is this true? Have tanks become really useless on the modern battlefield? No. Main battle tanks and other armored vehicles are not useless. It's quite the opposite in fact, and here is why. Tanks are not becoming obsolete because they can adapt to the modern battlefield. If the battlefield environment changes, so will the tank change in order to adapt to them. It is true that in the 1960s, tanks were almost made obsolete by the introduction of new anti-tank missiles. In the first half of the Cold War, there was no armor technology suited to protect tanks against shape-charge warheads. This was at a time when composite armor did not exist yet. An infantryman with an RPG could easily penetrate even the frontal armor of the most armored tanks, but then, big improvement began in the defensive sector, and tanks made their coming back with more protection than ever. As far as anti-tank weapons have advanced, the protection efforts for tanks have also advanced too. Active protection systems and add-on armor really help to increase the survivability of tanks on the battlefield. Main battle tanks are still the best and most efficient system that can combine firepower, mobility and protection, no matter how good the anti-tank systems that are used have become. With the advent of new add-on armor and active protection systems, tanks are more viable than they were before. Aside from MBTs, not a lot of units can survive a hit from even a 60-year-old RPG, so, against modern weapons, they are the only thing that can stay alive more than few seconds. In fact, Other countries are just now beginning to produce their own tanks, such as Turkey, with a very promising tank, the Altai, which is on the same level as the South Korean K2 Black Panther, considered to be one of the best modern tank in the world. And then of course there is also the even more vulnerable infantry fighting vehicle, which transports the soldiers because infantry also needs to be transported over long distances somehow. And tanks are a good support for infantry fighting vehicles, like a big brother, protecting the vulnerable infantry transport vehicles against enemy tanks and providing heavy fire wherever needed. Tanks can breach through heavily defended enemy lines where most other units would struggle and suffer heavy casualties. And most importantly, since APS makes it now very difficult for infantry to destroy tanks with missiles, the only way to destroy an enemy tank that is equipped with APS is with an APS-SDS penetrator from your own tank, since most active protection systems are useless against APS-SDS penetrators. So the tank will still remain a very valuable asset on the modern battlefield for the next decades.